What's up everybody, welcome to another Python 3 recipe. In today's video we're going to talk about sorting with custom defined keys. So in this case the problem statement is, let's say we are still building our blog and we are having a lot of comments on our blog post, and then comes the time when we want to sort comments based on their length to show at the upper of the list of comments the ones that are longer, or we want to show the comments with the most likes upper. So we want to sort the comments based on either on their length or the number of likes. How do we do that in Python? Because if we have a list of comments with each being represented either as a string, a tuple, a dict, a named tuple, just using the sorted function or the sort method as they come out of the box won't allow us to do this custom ordering that we are willing to have. And for proof, let's run this first snippet. Here you see we just have this list of strings, which are a list of comments represented as strings, and we sort them just using the sorted function without providing anything. And the order that's been applied is the lexicographic order, which is the order of the dictionary. In such order, A absolutely comes first because it starts with an A, and then I prefer, and then Python 3 is awesome, and then yeah, because it's based on the sequences, the elements that we have in this list. This is the one with the key that should come at the end. So this is the lexicographical order, and this is the default sort mechanism, how Python will sort these comments by default. But remember, what we want is to sort them based on the length, based on their length. We want to sort each comment based on its length. In order to achieve that, what we do, we pass to the sorted function this additional parameter, which is key equals to length, and what this does is instruct Python to compute the length of each of the comment and sort based on that length instead of the lexicographical order. And that's why we have now, with this way of doing, yeah comes first because it's the shortest instead of coming last, and then absolutely because it's the next shortest, and so on and so forth. But remember, what we actually want is to have the longest comment first. Hence we have to add the flag reverse equals true, which will not only sort based on the length of the comment but also reverse in order to have the longest one appear first, which is what we get here. Now let's say instead of mere strings, our comments are much more than that. A comment is a tuple with an author, a content, a number of likes, and a date. Then let's say we want to sort now based on the number of likes. But before saying that, let's see what happens if we sort just with the sorted function coming straight out of the box from Python. What happens? Well, Python will just compare the first, what Python will do is compare the first element of all the tuples, and since they're strings, Python will sort them based on the lexicographical order, and that's what happens here. You have Amy, which starts with an A, then Amy again, and then J, and then P, and then Z. So that's how Python will sort. And since these two, we have two comments from Amy, so these two are the same. In that case, Python moves to the next element in the tuple, which is anyone, and then yeah, and you can see based still on the lexicographical order because the second element is still a string. This one should come first. That's why you have this order. But that's not what we want. Actually, we want the comments to be sorted and to have the one with the most comments, the most likes first. So in order to achieve that, we are going to use the itemgetter and provide the key itemgetter2 to the sorted function along with the reverse equals true. And by doing that, what we are telling Python is actually to say that for each of the tuples, we want to sort based on the item 2 on the tuple. So what is item 2 is 0, 1, 2. It's the like. So that's why we say itemgetter2. So Python will come for each of the tuple, compute, like get the number of likes using the item getter that we have provided here, and sort based on that and not based on the lexicographical order as we saw before. And that's why we have now 15, the comment from Amy, which has got 15 likes coming first, and then 10, the one from Paul, and then 8, and then 5, and then 2, and then 0, the one from Zach. So just for completeness, we could have achieved the same using a lambda function, but just that itemgetter is less verbose and less typing and less boilerplate, but it works the same. It works absolutely the same way. But itemgetter is just more convenient for some people, and you're free to use either. It works the same. So let's say now, instead of list of tuples, our comments are represented as list of dictionaries. How can we sort based on the number of likes if a comment is represented as a dictionary? Well, our good friend itemgetter still applies here. We can still do the same thing that we did earlier. We just use itemgetter, but now instead of passing the position, we actually pass a keyword, because dictionary are indexed based on keywords, and to get an item in the dictionary, you get it by keyword and not the position. So here Python will do the same thing that it did for the tuple, but get the element by which we want to sort based on the keys. And again, you could have done the same thing using this lambda function here. It will have done the same thing, and as you can see, the order is correct. The comment from Paul comes first, it has 10 likes, then the one from Junior, 5, and then the one from Amy with 2 likes, and then the one from Zach with 0 likes. What about named tuples? Let's say our comments are represented as list of named tuples. What happens in this case? Well, as we said, when we saw named tuples, a named tuple, whatever a tuple can do, a named tuple can also do. So we could have done the same thing for named tuples that we did here. It would have worked, it would have talked, and let's even try to do it actually before using the very syntax that is much cleaner with named tuples. Let's replace this @getters likes here by itemgetter, and it should work fine. It should work very fine. We are sorting. The one with 10 likes comes first, then the one with 5, then the one with 2, then the one with 0. But if you are going for named tuples, we better go at full speed, because the reason why we went for named tuples is for readability. And here we are losing that, because when you're putting the position, we don't know what is at this position. At least it's not very explicit. And that's the reason why we want @getter instead of itemgetter for named tuples. And what actually Python will do internally is pretty much what this lambda function is doing, is sorting based on the likes, and how you get that from a named tuple. You get the attribute likes like this, and that's how Python will do. So it will come on each of the named tuple, get the likes based on this syntax that you have provided here, which is what you do when you're sending this @getter likes to the key as key to the sorted function. This is exactly what you're accomplishing. Last but not the least, what if we want to sort not only by the length of the comment. Let's say we want to sort by the comment length on a named tuple. You can do it like this. So you can sort it this way, oh, come on. Last but not the least, let's say we want to sort based on the length of the comment contained itself and not based on the likes. Here, in order to achieve that, what we do is simply we pass in a lambda function, and instead of putting likes like we did here, for example, we compute the length of the comment contained like so. And here you can see, and since you are returning reverse equals to true, then we want the longest comment to appear first. So that's why we have this one, which is the longest, followed by this one, which is the next one, and then this one, and then finally this one, which is the shortest comments. So that's how you sort. You can build much more complex sorting mechanism to customize the way sorted works, or the sort method works. And for sake of completeness, we have used in these examples, in all these examples, the sorted function, but everything that we said applies for the sort method. So yes, that's about it for this video. Hopefully you have learned something new, and if the case, please give it a thumbs up, and thank you all for watching. See you in the next video. Ciao.